Of course, you need to know your syllabus objectives so you know exactly what you need to learn for your exam. So they expect you to know how to derive the identity cos squared x plus sine squared x is equivalent to 1. You learn about this symbol just now, right? Use the identity tan theta is the same as sine theta and cos theta. Use the formula for sine a plus or minus b, cos a plus or minus b, tan a plus or minus b. Derive the multiple angle identities for sine 2x, cos 2x, tan 2x. Use specific objectives 7, 8, and 9 above. So those are these 7, 8, 9. It's supposed to be to prove, right? To prove simple identities and find the solutions of simple trigonometric equations for the range theta is less than or equal to 2 pi, including those involving the use of cos squared x plus sine squared x is equivalent to 1. So all of this, if you didn't do it already, or if you have no idea what you're talking about, will seem very confusing. But don't worry, that's what we're going to do, right? So let's start. Trigonometric identities. So the first thing I would want you to know, well, the first thing you should know is what exactly is an identity? Well, the definition of an identity in math is an expression which is true for all values of a variable. Most times people mix up identity and equation, but they're two different things, right? An identity is not an equation. But what exactly is the difference? Well, an equation is true for only certain values of a variable. Example, if I gave you that x plus 1 is equal to 3, and I ask you to find the value of x, that's easy, right? You transpose. People who would here with me, transpose just means to make something the subject of the formula, right? So if you want to find the value of x, you make x the subject of the formula. You're trying to get x by itself. So what would you do? In this case, if I have x plus 1 is equal to 3, I would minus 1 on both sides. So my answer is x is equal to 2. But if you look on this side, I'm saying that this right here is an identity. X squared minus 4x plus 3 is the same as x minus 1 and x minus 3. You see, so equation, only true for certain values of a variable. The only number that x can be in this equation is 2. If I put x is equal to 3, that would not satisfy the equation. Why? Because if x is 3, then 3 plus 1 is equal to 4. According to this equation, x plus 1 is supposed to give me 3. So the only possible solution here is x is equal to 2. The only number that x can be is 2. But for an identity, so you understand that so far with the equation before I move on to identity? It's only true for a certain value of a variable. The only possible answer I could have here is x is equal to 2. That's the only thing that would satisfy this equation. Why? Because 2 plus 1 is equal to 3. I can't have any other number plus 1 that is going to give me 3. You understand that? Yes or no?
Yes, misunderstood.
Okay, that's one person. What about the rest? You understand the equation concept? Not identities yet, right? Just the equation. You understand what I was talking about with the equation? I just need one more person to answer.
Yes, miss.
All right, next. Okay, so how exactly is that different from an identity? Identities are true for all values of this variable. So people are joining, right? Let me just clear this off. If I have that x is equal to, okay, I think it would be better if I wrote it out for you so you could actually see what I'm talking about instead of me explaining it in words, right? Seeing it visually would always help. Hold on. Okay, let me write it down. So I'm given this, right? X squared minus 4x plus 3. And I'm told that this is the same as, so that's what this symbol means, right? Just note something. This means equal to. This means the same as. This is for equations. This is for identities, right? Just note that the symbols are different, right? So they're telling me that x squared minus 4x plus 3 is the same as x minus 1 times x minus 3. Definition of an equation is that only certain values of the variable is true. It's only true for certain values of the variable. Identity, it's true for all values of the variable. So what exactly do I mean by that? Well, I could take x. So x is my variable here, right? For any value of x, so let me say this is my left-hand side, right? So let me just put left-hand side. If I say that x is equal to 2, then 2 squared minus 4 by 2 plus 3. 2 squared is 4, minus 4 times 2, so that's minus 4 plus 3, that's minus 1. Okay, so that's my left-hand side. If I check the right-hand side now, and I also use x is equal to 2. According to this symbol, whatever value of x I put into here, you see this answer? I'm supposed to get it on this side as well if I substitute 2 into this expression here. So let me just show you that. So I said when x is equal to 2, and I subbed it into here, I got the answer to be minus 1. According to this symbol, if I sub x is equal to 2 into this expression here, I'm also supposed to get minus 1. So let's see if that's true, right? This would become 2 minus 1, 2 minus 3. 2 minus 1 is 1, and 2 minus 3 is minus 1. 1 multiplied by minus 1 is going to give me minus 1. Okay. So when x is equal to 2, both of these answers are minus 1. But what if I had x is equal to 3? According to this symbol, which says that this is an identity, whatever value of x I put in, I'm supposed to get the same answer on both sides. So let's see if that's true. So we just found out that when x is equal to 2, I get the same answer. If x is equal to 3, then 3 squared minus 4 times 3 plus 3. So that's 9 minus 12, that's minus 3 plus 3, which is 0. 3. 3 minus 1, 3 minus 3. 3 minus 1 is 2, right? But 3 minus 3 is 0. Anything multiplied by 0 is going to give me 0. Okay, so when x is equal to 2 and when x is equal to 3, I just found out I get the same answer on both sides. Let's do a big number now. Somebody call a big number.
19.
19? That's what you said?
Yeah.
Okay.
Yes, miss.
So let's see if 19 works. Because of this symbol that tells me it's an identity, when x is equal to 19, I'm supposed to get the same answer on both sides, right? So that's what we're trying to prove now, that I will, in fact, get the same answer on both sides. Let me use orange. 19 squared minus 4 times 19 plus 3. So what's this answer? It's 19 squared minus 4 times 19 plus 3. 288, right? I'm supposed to get the same answer when I substitute 19 into this side, right? So let's see. 19 minus 1 times 19 minus 3. So that's 18 times 16. 18 times 16 is also 288. That's the definition of an identity. For all values of x, it does not matter what value of x I put in, I'm supposed to get the same answer on both sides. You understand that? Same answer, same answer.
Yes, miss.
Anybody does not understand? Going one, going twice, 3 times. All right. Ask me questions, right? I don't mind answering any questions. Okay, so now that we know the difference between an identity and an equation, these are the identities that you're required to know for your exams. So the first one is called the Pythagorean identity. Big word, I know, but it's not difficult, I promise. Cos squared x plus sine squared x is the same as 1. See the symbol? This symbol tells me for whatever value of x I put in here, my answer is supposed to be 1. So cos squared of whatever x is, so let me say x is 5. Cos squared of 5 plus sine squared of 5 is supposed to give me 1. Every single time for any value of x, I'm supposed to get 1. So let's prove that first. Before I show you how exactly they derive this identity. Squared x, and according to that identity, according to that just now, this is supposed to give me 1 for all values of x. So let's say x is equal to 5. When x is equal to 5, then cos squared of 5 plus sine squared of 5, it's supposed to give me 1. Okay, well, let's see. This is just something for you to note. Cos squared of x is the same as saying cos of x squared. So just note that, right? You would need this for future purposes. So cos squared of x is the same as saying cos x squared. All right? Everybody good so far?
Yes, miss.
All right. Okay.
Miss.
All right. So you have this written down, right? So I can erase it.
Miss, could you repeat what it says? Yeah, can you
This
repeat it? Yeah.
cos squared x can be written as cos x squared.
Okay,
It's
miss,
the
thank
same.
you.
So instead of saying cos squared 5, I can also write this as cos 5 squared. Plus, I can do the same thing for this one. Sine 5 squared. So anybody, can you put this into your calculator and tell me what you get? Cos of
Miss,
5 squared, sine of 5 squared.
I put it in and I got 1.
1. Okay, so it worked for when x is 5. What if I let me use a relatively big number. Let me just erase this whole thing, right? So we just proved when x is equal to 5, yes, this is going to give me 1. But what if I have a big number? Actually, let me use a really big number. If I said,
It's 188.
okay, 188. 188, 188. We said cos squared of 188 can also be written as cos of 188 squared plus sine of 188 squared. Can anybody tell me what's the answer for this when you put it into your calculator?
I got 1, miss.
All right. Let's see if you put a negative number. Let's see if that would work as well. Somebody give me a negative number.
Negative
Negative
9.
7.
Okay, fine, -7.
-7. Okay. Anybody tell me what answer you get? When I replace x with -7, what answer? Anybody, what answer did you get when you put it in the calculator?
Miss, I got a syntax error, so I'm retrying it.
Okay.
Miss, for some reason I keep getting an error.
Okay. Anybody else guessing an error? Anybody got the one? Okay, well, the answer is 1, right? So that means you probably put in something wrong into your calculator. So tell me exactly what you put into the calculator.
Miss, I put in cosine in brackets -7 squared.
Oh, wait, hold on. Might be a problem. So you did this.
No, miss.
Okay, repeat again.
Okay, so cosine with a -7 inside the brackets.
Squared.
Yeah, squared.
Okay, and what answer did you get there?
I got a syntax error.
Okay, something's wrong.
Miss, I got one.
What?
I got one. My calculator works.
Yeah, you put to get 1. So what answer did you get when you put this into the calculator? You get syntax error?
Yes, miss.
Yeah, well, that's not supposed to happen. You're supposed to get a really long decimal.
Miss, he can try put the bracket not before cos but before the negative sign. That's what I did.
Most calculators do it automatically, but if your calculator doesn't, then that's probably the reason why. Try doing it like this.
Okay, miss, I'll give it a shot.
Tell me what you get. I won't move on until I know that you understand.
Oh my, I still got a syntax error. That doesn't make sense. What mode is my calculator supposed to be? Isn't it supposed to be in degrees?
It actually doesn't matter.
Oh, okay, all right. Well, for some reason I keep getting a syntax error.
Okay, that's a problem. All
Oh, no,
right,
miss, let me try something like another calculator.
all right.
I'm going to type in like calculator online and see what that gives me.
Okay, so while he does that, let me start drawing. Oh, let me start writing about what I'm going to do. So let me know when you get the 1, right?
Okay, miss, I got it online. One.
All right. So we just proved that this is true. Well, we just did some values of x, right? But according to this, for any value of x, any value I put into this, my answer is supposed to be 1. Okay? That's what identity means. That's the definition of an identity. But this Pythagorean identity, long word, what is that? Where did they get this from? Well, let me explain. Say you have a triangle, a right angle triangle. So this is my Cartesian plane, y-axis. This is my x-axis. Say I have a right angle triangle. So this is my right angle here, right? And this is my angle theta. Whether theta is in degrees or radians, it doesn't matter, right? Okay, so that's a theta sign. That's right. That's a theta sign to represent the angle. Say this angle is labeled, this side of the triangle is labeled 1. This side is called the hypotenuse. This is labeled y, and this is labeled x. If I wanted to, actually, hold on. Before I explain this one, let me show you the other one. It would make more sense if I show you the other one and then this one. So, sorry about that. We're coming back to this very soon, right? I just explained this one and then go into that one. It would make more sense to do that. So maybe I'll switch the both of them when I'm editing the PowerPoint. So I'm going to prove to you this identity. This is also an identity you need to know. Tan theta is the same as sine theta on cos theta. But the question is, how exactly did they come up with that? Did it just, appear out of nowhere? No, it did not. So like I said, my triangle, right? This is a Cartesian plane, y-axis, x-axis. This is a right angle triangle. And this angle right here is theta. So I'm just calling it theta, right? Whether it's in degrees or radians, does not matter. This side, my hypotenuse, I'll label it 1. This length here is y, and this is x. So when we are doing radians, we mentioned the trig functions sine, cosine, and tan. And we went through that each of these trig functions have specific formulas, right? We know that sine theta, so sine of an angle, right, is equal to opposite on adjacent. What do I mean by that? When I say opposite, I mean the side opposite to the angle. So this is my angle theta. The side opposite to the angle is y. And then the hypotenuse, that's what h means, would be 1 in this case, right? Side opposite to the angle theta is y. Hypotenuse, which is the longest line in the triangle, is 1. Anything divided by 1 is itself, right? So y on 1 is equal to y. If I say cos of theta, we know cos of an angle is the adjacent side on hypotenuse. And this is going to be equal to, so the adjacent in this case is x. And the hypotenuse we said is 1. The hypotenuse, longest line in the triangle. Anything divided by 1 is itself. So x on 1 is equal to x. Tan theta. We know the formula for tan theta. Okay, I don't really have space down there, so let me go up in. It's the same thing I'm writing down. Tan theta, so yeah, is equal to the opposite over the adjacent. So the opposite side over the adjacent side. If I look at this triangle, okay, so this is my angle theta, right? Can any one of you tell me which side is opposite to angle theta? 1, y, or x? Which side?
Miss, I would say y.
Y. Which one is adjacent?
That would be X.
X.
Yes, good job. So just a little tip, you know, just to help you remember which one is the adjacent side. So this is my right angle. Ooh, pretend that's a right angle triangle, okay? And this is my angle theta. The adjacent side is always the side that has the angle theta and the right angle, right? So wherever you see the angle theta and the right angle, that's my adjacent side. Okay, that's just a little trick to help you remember which side is adjacent. For people doing physics, that will come in very handy. Okay, so tan theta is y on x, but we just found out here that sine theta is equal to y and cos theta is equal to x. So instead of putting y on x, I can say sine theta on cos theta. And that is how they came up with the identity. Tan theta is the same as sine theta on cos theta. Everybody good with this?
Yes, miss.
Okay, that's one yes. What about the rest?
Yes,
Everybody
miss.
in it? All right. All right. So what I was saying before, this whole explanation just now is going to help me to explain the Pythagorean identity, which was the first one, right? So we just found out sine theta is equal to y and cos theta is equal to x. So instead of putting y on x, I'm going to put sine theta and cos theta. So y is the same as sine theta. X is the same as cos theta. So just erasing this bottom part. Does anybody remember Pythagoras' theorem?
Probably miss.
What is it? Let me just put pi. Can you tell me what's the theorem?
Okay, never mind, miss.
Anybody remembers?
Something with a pendulum where, like, when it swings, like the angle, it meets. I don't know. I'm talking about. I'm thinking about physics when I hear about Pythagoras theorem.
Pythagoras' theorem doesn't have anything to do with that. What?
A squared plus b squared equals c squared.
A squared plus b squared equals c squared. A squared plus b
I'm not
squared.
feeling too well today, so I may not be as responsive.
Yeah, that's fine. Hope you get better soon. A squared plus b squared is equal to c squared. Or you might see the hypotenuse squared, so I'll put h squared to represent hypotenuse, right? The hypotenuse squared is equal to a squared plus b squared. Sometimes you might see a squared is equal to b squared plus c squared. It doesn't matter, right? They're just letters. Whatever works for you. So I'll go with this one, right? Just so that I have the h for hypotenuse. So hypotenuse squared is equal to a squared plus b squared. Like I said, these are just letters. You could use whatever letters you want. It really does not matter. Hypotenuse. Which side is the hypotenuse? 1, y, or x? Well, 1 sine theta or cos theta? 1, y, or x? Which one is the hypotenuse? Yeah. Yeah, it's 1. So that's 1 squared is equal to a would be this side. So let me put y squared plus b, this right here. So to remember that, you could say b for base of the triangle, right? So b is x squared. But we said that y is the same as sine theta and x is the same as cos theta. So instead of writing 1 squared is equal to y squared plus x squared, I can write instead 1 squared is equal to sine theta squared plus cos theta squared. But remember, I told you before earlier on that cos squared theta can be written as cos theta squared. So what does that mean? I can rewrite this. I can write it as 1 squared is 1, right? So 1 sine squared theta plus cos squared theta. Right. And that is actually how they got yeah, sorry about that. Right. That's actually how they came up with the Pythagorean identity. So 1 is the same as sine squared theta plus cos squared theta. On the PowerPoint, you would see cos squared theta plus sine squared theta. But it does not matter. Why? Because addition is commutative. For those who don't know what commutative means, so we say that addition is commutative, multiplication is commutative. So what exactly do I mean by that? Say I have two numbers that's just represented as a, actually no. Let me use actual numbers. So 1 plus 2 is equal to 3. But I could also say 2 plus 1 is equal to 3. It's the same thing. That's why we say addition is commutative. It does not matter which order I put it in. 1 plus 2 or 2 plus 1, both of them are equal to 3. And that's why I was saying here, sine squared theta plus cos squared theta is the same as saying cos squared theta plus sine squared theta. Everybody good with that? Yes? No? Need me to explain it again?
Yes, miss, I got it.
Okay. That's one person. Anybody needs me to explain it again? No? Going once. Going twice. All right. Oh, I have less than a minute. You'll rejoin after this, right?